Today we're going to be graphing linear inequalities. Now, we've been graphing lines for some time now, and we've been graphing, actually, if I get specific, equations. We've seen equal signs in all of our problems that we were graphing. That's the only thing that's going to change. We are not going to be looking at an equal sign anymore, but rather than an inequality sign. And there are four inequality signs. If you remember, we have less than or equal to, greater than or equal to. So these are the four that we will be looking at today and furthermore for a while. So graphing linear inequalities. Now, how you graph the line itself doesn't change. Whether you want to use your y equals mx plus b, which is your slope-intercept form, using your slope and y-intercept, or if it's given in standard form, you can use your x and y-intercepts if you would like to graph. So your preference of graphing is still up for grabs. The only thing that's going to change is our answers. When we were graphing equations, the only answers were those that lie on that line. Now with inequalities, your answers or your solution will be shown as a certain region. So we get to get our colored pencils out or do lots of shading and coloring in with our pencil. So this is your cheat sheet right down here. You may want to copy this down, pause the video if you want, and copy this. This will be important. To me, it's all about the y-axis. And so I know a lot of you guys like to graph in y equals mx plus b, so this is going to be set up nicely for you. If you have a problem that looks like y is greater than, of course there's other stuff over here, you will shade above the line and the line will be dashed. If you have y is greater than or equal to, you are going to shade above and it will be a solid line, hence the sign equal to, everything included on that line. If you have y is less than, you will shade below and you will have a dashed line. And last, if you have y is less than or equal to, you will shade below and you will have a solid line. Now let's get into some problems and actually look at this. Let's take the first one we have here. Y is greater than 2x minus 3. So I put it in slope-intercept form. We're pretty good at that already. So I've already got it set to go. Let's do this. Let's find our y-intercept, which is -3. So I'm going to go down 1, 2, 3, and place my first point. My slope is a +2. So if you want to look at this as rise over run, we're going to go up 2 over 1, up 2 over 1, and repeat that as much as possible. Now watch, I'm going to go backwards here to extend my line onto the other side. I'm going to go down 2 and to the left 1. So here is a sketch of what my line is going to look like if it was an equation, y equals 2x minus 3. Now notice we have a greater than sign. So if you look back up at your cheat sheet that you have previously written down, y is greater. Remember we're talking about the y-axis. So if I have y is greater, I'm going to shade above the line, which looks like this. Above that line. So I'm getting, and all over here, it's a certain region. I am getting all values on the y-axis that are bigger than this point right here, where it crosses. I'm looking above it or below it, and since it was y is greater than, I'm going to shade above. Now let's also look at this, because not only is it about where you shade, it's also how you draw that line. And since our inequality has no equal to underneath, that means that my line needs to be dashed. So if you've accidentally drawn a straight line through, take your eraser and make some gaps in there. Reason being, any point that lies on this line is not going to work for this inequality. Now let's say you're having a hard time seeing where to shade. Even though it says y is greater than, you're going to shade above it. Let's take the point 0, 0. Let's take the point 0, 0, and this is what we're going to check. We're going to check if 0, 0 is actually a solution to this inequality. So what I would do is I would write the inequality down. Y is greater than 2x minus 3. And any point that I check, I'm going to plug those values in. So we've got a value of 0 for the x, and we have a value of 0 for the y. So I'm going to take that out, and I'm going to see what happens here. On the left side, I have 0 is greater than. Let's figure out what's over here. 2 times 0 is 0. 0 minus 3 is negative 3. Now let's look. Is 0 greater than negative 3? Yes, it is. So that's a true statement. So the side that you should shade should include the point 0, 0. And look, that's what we've done. The side that is shaded does color across the point 0, 0. So we shaded correctly. Let's go look at another one. Let's look at this. Y is less than or equal to negative 3x plus 4. All right, so it's in slope-intercept form. I'm going to go and graph my y-intercept. 1, 2, 3, and 4. My slope is a negative 3, so from that y-intercept, I'm going to go down 3 over 1. 1, 2, 3, run to the right. Again, 1, 2, 3, run to the right. Again, 1, 2, 3, run to the right. Okay, I'm out of graph paper here. Now let's look. Y is less than or equal to. Now, less than means we're going to shade below if you look back up at your cheat sheet. So, below, where are we talking about? See where it crosses the y-axis? And this may be helpful. Is if you went ahead and drew your line. So let's do that first on this one. Y is less than or equal to. It has an equal to sign, so I'm going to have a solid line, including all points on that line will be true. Now let's look at it as far as shading goes. Y is less than. It crosses the y-axis up here, so where are all values less than this point? I think you would say below. That's why your cheat sheet says to shade below. So we're going to shade below this line. And this entire region to infinity and beyond, if we had more graph paper, it would work. So let's do this. What if you're still not sold on the fact that I shaded the correct spot? Let's do a check. An easy point to check. Let's do this one. 0, 1. Let's check 0, 1 and see what happens. So remember, I'm going to place my x-coordinate where my x is. And I'm going to place the y-coordinate where the y is. Let's check and see what happens. So on the left side we have 1 is less than or equal to, let's see what's over here. Negative 3 times 0 is 0. 0 plus 4 is 4. Now let's check to see if this is true or false. Is 1 less than or equal to 4? Yes. Here's the point, and we shaded the area that has that point in there. Let me show you what happens if you wanted to check the point 2, 1 over here. Let's check 2, 1. So my y-coordinate is 1. That goes over here. My x-coordinate goes right beside the negative 3, in this case, which is 2, plus 4. All right, let's check. Negative 3 times 2 is negative 6. Negative 6 plus 4 is negative 2. So this is what we're looking at right here. Is 1 less than or equal to negative 2? Absolutely not. So you would not shade the area that includes that point that you were trying to check. That's why our original shading is true. We'll work more problems in class. See you then.